So welcome everyone. I think it's a Friday, so we should have another like 1 hour of time spent on learning something new for most of us. Um, I think everyone who I see on the call today is probably joining for the first time. But if any one of you have attended the session prior to this one, then please leave it on a chat window. Some of the concepts I will cover will be a bit of a refresher for you then and a repeat and before we jump into the case studies. Okay. So yeah, I'm Vinesh Solanki. I'm really excited to see all of you. We will be covering the two key technology that I personally really follow for last many years, which is AI and IoT. Um, a brief note about myself. Um, I'm in love with technology for past 22 plus years. Um, and I've worked in different business functions and different departments and different skill sets covering business development, strategy, partners, sales, and of course, technology development and solution selling in AI, IoT, digital transformations, mobile payments, Wi-Fi, and investment banking. Currently, I head the business at Nash Industries with the responsibility of driving OEM and ODM business for our clients across the world, almost across 15 countries. Prior to that, I was running Napino Digital Solutions, which I started as a department from scratch under Napino Group. And before I left there, roughly around 3.5 years, I scaled it to 200 plus employee. Um, and across many companies prior to Napino, I've played different roles at Lenovo, Airtel, Goldman Sachs, and TCS, out of which Goldman Sachs is something I worked for almost 8 years. I hold an MBA from IIM Ahmedabad, which I did in general management with a focus on AI and IoT, and a master's in computer science from State University of New York in USA. Because of my personal motivation and passion, I run multiple communities, one of which is IoT NCR with 8,000 plus members. Then few other groups and forums like IoT Thought Leader Forum, and so on. And then, of course, I love to always talk and speak about what I know limited. So I've been fortunate to present my thoughts at NASCOM, TEDx, um, Your Story, EFI, etc. Feel free to connect with me on LinkedIn. That's my LinkedIn profile link. You can just search by my name. Of course, a lot of what I will cover today will be from this book, which I have written and published last year, called as Confluence of AI and IoT, A Marriage Made in Heaven. So this book have close to 18 case studies. If you wish to buy the book, you can scan this QR code on your screen or reach out to me if you want an author signed copy, and I will be happy to send you one at a discounted rate. Of course, the book talks the power of these two technology, which is what we will cover in the next 55 minutes together. Okay. Um, I think what I will spend close to 15 minutes to 30, 15 to 30 minutes, just quickly covering the fundamentals of IoT, the transformation stack, the potential and the impact of this technology in the industry, and a bit about industrial IoT or Industry 4.0. And then after that, we'll jump into the case studies. We might not be able to cover all of this today, but maybe I will cover Siemens, then Black& Decker, and one of the energy management case study. If time permits, we'll get a glimpse of Tata Communications and electric vehicle use of AI and IoT. And then, of course, because this session is recorded, I will share with all of you and including those who have RSVP'd. But maybe I will conduct some few more sessions on some specific areas like smart agriculture, which I have not done so far. I have a case study on avocado farming that I will cover later in the next session. And another two beautiful case study, one with the use of robot in a retail store, and one is more around the use of AI and IoT in waste management in a smart city, Jabalpur in India. Okay. So I will give you some opportunity to ask question, maybe one or two in the between, and at the end of the session. Okay. But if in meanwhile, if you have question, please post it on the Q&A on the chat window of this event, and I will take it up at the end of the session. So let's start with the fundamentals of IoT and AI. But before that, I think you all should be aware of some of this very critical terminologies, right? So the first one is, of course, transformation. Feel free to write your thought about transformation on the chat window, but what is transformation basically means is actually transforming something from form A to form B for good, or something to make it better, or to improve it, right? That's transformation. And I think of late in the last many years, we are hearing digital as a word with transformation, digital transformation. So that means transforming a process which was probably not digital before into its digital avatar, right? It could be the KYC process that we all do today with the banks. It could be the Aadhaar authentication. It could be the payment that we do with UPI or online. It could be the transformation of an industry to adopt technology to become more efficient, more productive, or more compliant with the norms of the industry, and so on, right? But along with those two words, what comes is these four other words, right? One is M2M, machine to machine. That technically means nothing but two machines talking to each other to do some task, right? It could be the machines in the Coca-Cola bottling plant, right? Which are talking to each other, like the machine that is filling the soda or the Coke in the bottle, talking to the machine that is cleaning the bottle to ensure that it is filling the bottle only after it is cleaned properly. Then, of course, a lot of our time today will be spent understanding these three other words: Internet of Things, Industry 4.0, okay, and AI. I think we all have heard this word, so we know what does they mean from a usability perspective. But we will try to uncover the technological uh, complexity behind it in a very layman way, and how they combine together to implement the technology solutions required in different industries, like the one that we will study today, which is Siemens factory, or the Tata communication implementation for a transformer. Okay. So as we go forward, I think it is important for all of us to understand the impact of networks. Um, um, the world started using networking or transforming or transferring data with each other in the 80s, right? Using a standard called as ARPANET on the ARPANET network. And then we'll move towards document sharing using protocols like file transfer protocol, FTP, right? Then we adopted internet and started conversing or using internet for commerce, which is the dot-com era in 1995. Then in came social network in 2000s, where definitely we said, why don't we talk to each other more frequently on a social media platform? And even before Facebook, there was Orkut, there was MySpace, there was many other standards, and of course today we have LinkedIn, Twitter, Insta, etc. And then maybe between 2010 and over to 2013, the technology like AI and more so the concept of Internet of Things, where you can connect things to the network, to the internet, to make them more usable, okay, for all of us, whether as a consumer, like our smartphone or smartwatch, or whether for industries, or whether for a retail store or a warehouse, or even connecting our car to the network, right? Smart cars, autonomous cars, and so on. So from left to right, as you see the pattern, the network is becoming more complex. More and more things are coming on the network, and it is becoming more and more connected. And it is happening, and it is becoming possible because internet is becoming widely available to all of us. It is becoming cheaper. It is becoming more fast and more reliable, right? So with that, let's understand the basics of IoT. So if I think of a human being as an human being, we use different sensors on our body, like our eyes, to see something like a hot mug, transfer that information over our nervous system onto our brain, right? Which computes and tells you, hey, don't touch that hot mug. It's hot and you might get burned, right? If I map the same to in a very layman way to the technology stack of Internet of Things, it is composed of three things, three pillars, I would say. One is sensors or hardware or devices or actuators. Second is the internet, the network, and third is, of course, the computer, right? Or the AI, or the engine, or the machine learning that is actually making sense out of the data that is captured by the sensor. In this case, it will simply say that maybe it is hot, or if it is a fire alarm or a smoke alarm, smoke sensor, it will tell you that there is a fire in the room or there is a smoke in the room, right? But if you combine these three, which is the computer, the compute, the AI, the network, the connectivity, and the hardware, which is the acting as a sensor, it becomes really powerful and magical for all of us. So when did this term get coined? It was coined in 1999 by Kevin Ashton during his presentation at P&D, Procter and Gamble, when he simply said, why can't we use RFID tags in the supply chain to monitor the movement of our goods from our factory to our warehouses, from the warehouse to the distributor, from the distributor to the retailer? Okay, so that at least we know the status of our supply chain in a more real time or near real time way. So he said that he simply said that when we connect a system where the internet is connected to the physical world via ubiquitous sensors, he defined IoT in that way. Okay, but of course, many people define IoT today in different way or terminologies, but at the core, they all mean the same that we just learned in the previous slide. How I define Internet of Things, I call it a bit more complex way because, of course, I'm a practitioner. I'd like to say the things in the way that it covers the whole value. So the four key words are the share, analyze, tools, and value. An ecosystem of connected objects which enable multitude of devices to share data. Okay, and analyze that data using the captured information by AI or machine learning to enhance what? To enhance operational effectiveness and deliver value to all stakeholders. So ultimate idea is if I want to make a system more usable, more value generating to all the stakeholder of that system, whether it is a factory or whether it is a car or whether it is a smart office or a transformer or anything, ultimately I need to employ two technology together. I need to capture data and I need to process the data, right? So that's simply called as AIoT or AI plus IoT today, right? But let's go a bit complex, a bit deeper. If I just map the definition I defined for you earlier into these three vertical buckets. So the first bucket is IoT devices, which is Bluetooth, Zigbee, LTE, anything that is used to connect those devices to the network, right? So you see the devices are a combination of camera, or it could be a mobile phone, a car, or a factory machine. I'm connecting all of them to a gateway called as IoT gateway. And then using that gateway, I transfer the data to the public internet. Uh, uh, and it goes and gets resides into a cloud or a remote server. Okay. And I could be using a cellular connectivity like 2G, 4G, or 5G, right? Or I can also use Ethernet or fiber optics, right, to transfer the data. But the idea here is that the device to gateway is communicated over the last mile protocols like Bluetooth, Wi-Fi, Zigbee, LTM. Okay, but the transfer of data from the gateway to the internet to the cloud happens over a long range connectivity. The role of gateway here is nothing but to capture the data from the end nodes or from the end devices or sensors, convert that data maybe into some structured format. Sometimes it might also be called as edge gateway or AI-enabled edge gateway, where it might be doing some logic at the end at the gateway itself. Think of a camera deployed to monitor the safety in a cricket match in a stadium. Maybe a lot of time it would want to process the image or the video at the gateway itself and alert the local authority or the local security to inform about something suspicious, right? It will not be able to wait for the entire data to go to the cloud, get processed, and then the alert come back to the security guard or the security personnel. That's why it's called as edge gateway in that case. The camera itself might be the intelligent camera, or multiple camera in the cricket stadium might be sending the data to a local server or local gateway or a processor inside the stadium itself. Okay. So that's kind of the way it could be deployed. Fine. But if I show you some examples of this hardware devices or sensors, it could be things like the smart caps, headbands, fitness tracker. It could be router, edge gateways, access point. It may be a camera like an ADAS camera used in a smart vehicle for tracking the health of the driver or monitoring and alerting the driver of some situations, or a vehicle telematics device. It could be a smart water purifier, smart speaker, smart doorbell, surveillance camera, Wi-Fi plugs, or even some products which are used in the industrial or agricultural setup, like a smart farming device for monitoring the health of the soil, or alert the farmer of the weather pattern, or data logger, or anything like that. Overall, all of these are nothing but hardware or electronics which are meant to capture certain information in their environment or in their surrounding. But once they are captured, what you do, you basically capture them from different type of sensors, right? You can have ambient light, pressure, motion, proximity, temperature, humidity, etc. Or even water flow and etc. or gas leak, right? So you enable this kind of environmental data to be captured and then store it somewhere. But you must be asking question that what kind of hardware can I use as a practitioner or as a student or as a beginner in to learn IoT and build some solution on top of that by employing machine learning. One of the most widely used of these are Arduino board that you see here. You can find it online. Simply buy, and there are a lot of tools these days actually that can enable you to write a simple smart LED program for yourself. Okay. So before we jump into the case studies, I want to talk a bit about the digital ecosystem. Typically, if I break down my three pillars, right? The hardware, the connectivity, and the AI. The hardware will be comprised of device makers and resellers and hardware programmers. The connectivity is provided by network service providers like the Airtel, Jio, or the people who provide you standard last mile connectivity like LoRa, Sigfox, Zigbee, other standards. And then comes the people who actually make the sense out of that data and build the end application or solution for you. They could be broken down into system integrators, software solution providers, go-to-market partners, data scientists, and domain experts, right? So the idea is between these three buckets, you have the entire ecosystem that plays a role in the AIoT solution stack. And then comes, of course, the end user or the end customer, which is using this application. So think of an example. A smartphone is actually an IoT device which has multiple sensors, GPS, camera, and it also has the application written by somebody, downloaded by you on a Google or an Apple Play Store to monitor the number of steps you walk in a day. But ultimately, there is a sensor that is counting the steps that you're taking, maybe a gyroscope or an accelerometer. And then there is a guy who has built an application for you to make sense out of that data to tell you about your health or number of calories you burnt, right? And then, of course, there is internet inside this phone. So all the three player that you see that makes that smart health tracking application possible is in this stack, right? But additionally, the role are also played by a supporting ecosystem like standards and research bodies, innovation hubs, and so on. Based on my 10 years of research in this industry, I think the device or the hardware ecosystem makes 30 to 40% of the total revenue in an AIoT solution. The network provider or the internet provider makes 4 to 5%, but of course they make it recurring every month as a subscription revenue. And 55 to 60% is roughly made by the stack at the top, which are the people who build the application, make the sense out of the data, the domain experts, the data scientists, the system integrators, and the software providers or application provider. Okay. And they might be also charging you either as a one-time license fee or as a subscription model on a SaaS model basis. You should go through this slide later on. I will not spend too much time, but this was a good analysis of by IoT Analytics that what kind of connectivity play a role in the entire IoT protocol stack, starting at the physical connectivity layer, going all the way to the end usage, which is the analytics and the end user. There are different standards and protocol that actually play a crucial role in making the entire AIoT stack possible for you. Okay. So let's start with the impact of this technology stack. So now we have learned in the first few minutes that how the stack looks like and what role the different pillar play into that. But if I look at the complete market, right? So market research companies like McKinsey, Gartner, etc., they have come out with different numbers. And one of the average number that I've realized is $4 trillion impact of economic impact that this technology can have by 2030. Okay, there are already close to 17 billion IoT devices connected across the world, or devices connected to the internet. Sorry, and there are multiple companies already selling IoT solution. So this impact is not something that is not possible, I think so, in the next 5 years. But if I break it down further, the same $4 trillion into subcategory, I would say they are broken down into this nine verticals. The first vertical is the impact of AIoT in factories, which is for operations management, or you can say predictive maintenance and farm yield management. I think McKinsey and the other bodies, they say that between 1.4 to 3.3 trillion value will be generated in factories alone and in agriculture, these two areas. And that's why the case studies that I will cover today will be covering the operations management and the smart factories or industrial IoT area. The second biggest industry that will adopt IoT and AI together and generate value is healthcare. Okay, human health. So monitoring your health remotely or treating you in the hospital or after your surgery, right? So remote patient care, or even the applications which use AIoT stack for improving the wellness. Like I was just giving example of the smart fitness tracker, or a smart BP machine, or a smart glucose monitor, or even any solution that can actually monitor your health. Like if you have watched IPL or cricket, if you watch, a lot of players, they wear a black color band on their hand. That's a company called as Whoop, WHOOP, that actually monitors a lot of your parameter of your health while you're playing or while you're practicing and training. Okay. Third category is work sites, which is smart offices, smart workplaces, smart warehouses, smart retail store. So this is broken down into operations management, like oil and gas operations, okay, and improved equipment maintenance. And of course, a certain applications are also found in constructions, like building constructions, port constructions, and so on. So the top three, factories, healthcare, and worksite, they take the lion's share. Then comes smart cities, okay, centralized and rapid traffic control, autonomous vehicle, smart traffic management like congestion lane. If you read news, you must have heard of this smart traffic light in Bombay, where they can monitor the amount of cars in a particular lane and accordingly change the timer of the signal, the traffic signal, right? In fact, recently I studied about an implementation of a audio sensor, like DB. It actually monitors the number of decibel of the in a particular lane, and the more somebody honks, the more the timer increases by that time. So it actually penalizes you if you're honking more than required. Okay, so that's one of the application there. Then of course there are other industries like retail, autonomous vehicles, ship navigations, smart home, then smart cars or smart vehicles for transportation, passenger vehicle, shipping, after sales service improvements, and then finally offices like human productivity, right? So between this nine segment and nine use cases, I think is where this $4 trillion of economic impact is coming into play. Okay. But you should also always ask this question to yourself and to the people around you, that why AIoT and IoT, or AI plus IoT, is becoming so relevant for all of us. Why would I adopt it, right? As a user or as a consumer? I think there are four key growth driver here that is making this possible. The first is the cost of the sensor. Okay, that has gone down from $1.5 to less than 50 cents now in last 10 years to 12 years. Then data storage cost. Again, it has gone down from $500 roughly to 2 cents now for 1 GB of data. That's a humongous reduction, right? In the last, you can say 20 years approximately now, from early 2000s to 2025. 2025 year, I think you can say that you can buy data at a cost of less than a penny now. Availability of multiple devices which are connected to the network, okay, which was earlier in 2000s was largely limited to specialized application like security camera. And today you can say it has crossed 17 to 15 to 17 billion connected devices. But if I only take IoT devices and if I take the mobile phones out of it, right, then only IoT devices, sensors and actuators, they have crossed roughly 9 billion to 9.5 billion, okay, across the world. So average consumer is also carrying 4 connected devices these days, from your smartwatch to your smart neckband to whatever. And the speed of internet connectivity has also increased drastically. We were using mostly 2G or 3G in 2000s, and now we are already talking about 6G, right? In fact, 5G has increased the speed of connectivity by 400,000 times to for all of us. So I think the possibility of this ecosystem to leverage the network is become very widely applicable. So keep this 4 driver always in your mind whenever you think of this stack in you for you. But also you should also, if you love IoT, you should follow this IoT analytics. I follow this for last close to 5 years now. I've read every report they launch, and their latest report in September 24 talks about multiple use cases, around 27 of them. And the top 10 are here. Starts with process automation, the #1 use case that is getting adopted globally. Then comes quality control, energy monitoring, real-time inventory, supply chain, operations planning, track and trace, which is #7, asset performance, remote asset, and then of course location tracking. So if you look at the top 10 and if you look at the global adoption from 2021 to 2024, each of them has grown to a substantial level. Of course, there is a lot of still adoption happening. But these cases are broken down into 3 categories by them. SO stands for smart operations, SSC stands for smart supply chain, and CP stands for connected products. Okay. Out of 27, the top 10 majority are in SO, smart operations, because that's where the most ROI is coming for the user. The most value is generating and getting generated for the stakeholders. If you remember my IoT definition in the 4th slide, it was generating value for all stakeholders. So the value comes from different area, reducing cost, improving margin, increasing profit, increasing productivity, efficiency, safety, security, data privacy, a lot of things, right? But of course, in my book that I cover as well, I also talk a lot about data privacy and security. While we will not spend too much time on cyber security or cyber intelligence today in this session, I plan to do one session only focus on cyber security in the ecosystem of connected network and connected devices. Okay, but it is very important that we also keep that in mind. Okay, so I think first 2 sections are covered by us now, which is the fundamentals and the impact of this technology. I will jump into Industry 4.0, but I will just quickly check the chat window if any of you have any questions. Akshay, please let me know if any questions, otherwise I will continue.
No questions as of now, Vinay.
Okay. So let's talk about industry or industrial revolution quickly. So if you see this, right, from Industry 1.0 all the way to 4.0, which we are today, and we are only talking about 5.0 now. Industry 1.0 in 18th century was basically using steam and water for running factories, mechanical production, right? So typically it was mass production, but one product on the line you produce mostly by humans, okay, with machines doing certain set of activity. In 19th century Industry 2.0, we moved to using electricity, electrical energy, and also we went to assembly line where we are focusing on one task and one person. So basically, one workstation, one person doing one specific task. So we were able to move towards job specialization, but also produce the same products in a much faster, more, you can say lesser cost and faster time with better quality. Then came 20th century when IT and information technology became more relevant. So the industry said that why don't I adopt automation and automate my lines, produce faster, produce better, reduce the dependency on human, but at the same time make human and machine work together and faster time to market. And then came 4.0, which is the last 10 to 15 years, where the cyber physical system, like connected machines, IoT, AI, cloud, um, and they all came together to say, I can make running your factories more efficiently by telling you what is going wrong with your factory, helping you to monitor your machine's health, helping to make it more safer for your people to work on the shop floor, and tell you the insightful data, which can make it more possible for you to do continuous learning, customize the mass production. So I can run 10 products on the same line. I can also interchange from one product to another much faster, which is called as changeover time, compared to what I could do in 19th century 2.0 or 3.0. Okay. So I think the case studies, the two case studies I will cover, will tell you the application of some of this 4.0 in the industry. Okay. And the factories definitely are looking at adopting this technology. So I also thought this slide will be useful for you to read later on. But if I break it down, the application of AI and IoT, especially in factories, the one that we saw on the McKinsey slide, right? You can break it down into 5 subsections. First is operations management, which is managing my operations more effectively real time. Second is predictive maintenance of my machineries, my tools, my equipments, so that I can reduce their downtime, or I can predict when they are going to fail or stop working, or reduce their yield. Third is human productivity, activity monitoring, like how is my human using the machines, how efficiently they are able to do their job. Do they have the raw material reaching them on time? Are they able to run the machine or operate to the best productivity and outcome? Or is there any safety incident that is going to happen? Okay, especially in the steel furnace setups, steel manufacturing, or rigs and oil and gas or mining industry, right? Um, Fourth is inventory optimization, like monitoring my inventory ratio, my inventory usage more efficiently in my setup. And fifth is human productivity by using augmented reality or virtual reality. Uh, Technically using a combination of technology to train my people better using AR, or to monitor and help them to repair certain things better. For example, I did one case study with an airline manufacturing aircraft manufacturing company in France, where we were able to use a combination of IoT and a bit of an AR for them to repair the plane when they come for repair or maintenance. Basically, they have a very stringent SLA from the airline to turn around the aircraft in the hangar, because even 1 hour delay can result in a loss of like monetary loss for the repair guys. Okay, so that was one of the use case that maybe I will cover in the future sessions. Then the next is farm yield. Let's skip that for now. But farm and hospitality, or hospitals, sorry, are also one of the bigger adopter of this area. Okay. Um, I think this you can read later, but you should definitely, if you're interested in industrial IoT, understand this word called as Global Lighthouse Network. Okay, there the 16 companies which are identified by McKinsey and World Economic Forum in 2018. So basically, they said that let us study 1,000 different production facility across the world and find who is the best to adopt AI and IoT or automation or cyber physical systems, right? So they came out with the 16 factories, which are called as the leader in the advanced manufacturing domain. One of them is the Siemens factory that we'll cover in the next slide, the case studies. And there are a few more like BMW factories and so on. In fact, there is one Tata factory also in this global lighthouse network in India. Okay. But what they really said that why they are called as lighthouse network, because these are the factories which have adopted technology in the best possible way to achieve productivity, high sustainability, very fast agility, speed to market, and customization. Like if you see the outcome of their study, the factory output in the first section increased between 4 to 200%, right? That's the impact. 200% is a humongous impact. Productivity increased between 5 to 160%. Cost reduction from 5 to 40%. Quality cost reduction from 5 to 90%. If you look at sustainability, they were able to reduce waste in their plant from 2 to 90%. Water consumption reduced from 10 to 30%. And energy efficiency improved as well. Agility, inventory reduction, again, lead time reduction or changeover shortening. Then speed to market and so on, right? So let's jump into the Siemens factory case study now. Just the concept that you just covered in the last few slides, that will all come into fruition here. Okay, I'm going to use a marker just to tell you better what I'm going to talk about. So if you see the Siemens factory here on the screen, basically this is a factory in Germany, in Amberg, and the factory produces multiple type of hardware in their shop floor. First is they produce PLC, programmable logic controllers, and they also produce HMIs, human machine interfaces there. Okay, there are roughly 1,200 employees across the setup, and they sell this product globally. Of course, PLC and HMI both are very competitive industry. So Siemens said that I'm actually facing a lot of challenges where I want to design my factory in such a way that I can use both human and technology together to have a very efficient outcome. Okay, of course, unlike India or China or Vietnam, the labor cost is very high in Europe and US market, and they also don't work second or third shift very easily. Otherwise, their overtime cost will be also very high. So they wanted to automate as much as possible. So if you see this factory, you can see one person standing here, right? There is one lady right here. There is one person right here, and there are a few other in other area. What you see here is basically multiple machines which are used to manufacture the good that they want, right? And then there are certain trays here at the bottom which are basically carrying the components, okay, which are the active and the passive components in a form of a reel, right? But you will also see that there is one more thing here, which is this autonomous vehicle, guided vehicle, AGV, right here. This is a trolley here, and there are markings on the bottom, which are basically used for the trolley to move around their shop floor, right? The similar setup is behind here, right here, and then there is one more setup right behind here, and there are a few more right here on the left-hand side, right? So this factory is basically laid out in a way and designed by them along with one of the technology partner to ensure that they can move the raw material very efficiently across the area. They can change over from one product, like from one SKU of PLC to another model of PLC or HMI. And they have the productivity and the dashboard real time available to both the people on the shop floor and the staff and the leaders sitting in the office on dashboard. Okay. So what basically they do, they use a combination of AGV, IoT, some sensors which are deployed at different area, RFID as well, and AI, okay, combined to run this factory. And I will tell you in the next few slides what they achieve here. So basically, this AGV is moving right here in this direction, right? They of course have trained the employee to work with the machine so that there is no incident, no safety hazard for the employee on the shop floor. Okay. So basically what they do in this setup, they have employed three areas, right? One is smart manufacturing, which is a combination of sensor, IoT devices, RFID tag to monitor every step of the production process. And the machine and products, they communicate with each other in real time, okay? Providing the data to the shop floor to optimize their production. And because of which they can achieve flexible production schedule, okay? So they can actually reduce the turnaround time of a particular product. But if they want to switch the product, they can do it in less than 2 hours. Instead of earlier, they used to take 2 days for switching or 1 day to at least to switch to a new product, maybe 7 to 8 hours downtime. And they also employ AGV so that they can transport the material and components within the factory. Okay, automated guiding vehicles. Fine. So you can see the robotics also is coming into picture here. So basically, as I said, the AGV is guiding that particular raw material, and what is happening on the screen, they know that now this material need to be loaded on chip mounter 2. So that is then going on the SMT line to do the PCB process, the PCB assembly process. And then the next process is actually the testing and other things. Okay. So if you look at this line here, which we just covered, right? The idea here is very simple. My line layout is also designed to work with the technology together, right? So that is why we always say that AIoT cannot just work standalone. You have to design the entire application of the technology in a very comprehensive way. Okay. So I think with this, they also said that I can employ digital twin in my factory, in Siemens factory, so that I can create a replica of my shop floor, which will help me to switch over the new product, which will also help me to know the status and the health of each machinery, whether it is my chip mounter, whether it is my AOI, whether it is my PCB loader, whether it is my our incoming quality inspection store, or and so on. Okay. Um, of course, this entire application took approximately 18 months for them to make it live. And while doing that, they captured so much of data that they employed some machine learning algorithm to understand how much time they take to make a type of an HMI or a type of a PLC on the shop floor. And based on that, they started finding what are the common mistakes or common errors or common issues they face. And the last was very important is employee training and collaboration. So while in that 18 months, they also ensured that they trained their worker to work alongside the robots and the AI system effectively. This helped them to ensure that they can run second shift with maybe much lesser number of people. At time, if required, they can also run the third shift, and so on. Okay. So the outcome that they received was production lead time reduced significantly. The factory operates with much lower error rate. They increase the productivity. They had lesser failure, better quality control, because they could understand what are the typical issues, whether the issue is in the raw material, or it is in the machine process, or it is in the manual handling of the worker or the laborer. Okay. And of course, they can quickly adapt to the changing in the product demand and specifications. Any question on this case study before I move to the next one?
No,
Okay.
Vinay, we can move forward.
Great. I think I will share some details about this case study, but exactly like Siemens case study, there's a very beautiful BMW and Microsoft case study. That also is part of the Lighthouse network. It is also in Germany. Actually, this plant has 3,000 connected robots and machines, along with 300,000 vehicles produced annually of BMW brands. So they use a combination of Microsoft Azure cloud storage, IoT, and AI, basically to detect what? They detect unusual noises in the system. So the idea is very simple. They have employed noise sensors and other type of IoT sensors and actuators to understand the unusual noise that can come in the machines. So before the mechanic is dispatched to repair that machine, they can actually make already a predictive guess that what is going wrong with that machine. Is it vibrating more than required? Is it actually producing noise or sound which is not normal for that machine? It could be a painting machine, it could be an assembly machine, it could be a stamping machine, it could be a lighting machine, or whatever step it takes to make a car, which are more than 1,000 steps, right? So I think they realized that when they employed IoT and AI, along with, of course, other technology, they were able to reduce the unplanned downtime of the press shop by 25%. What is the press shop? A press shop is nothing but the shop that is used to do stamping of steel parts, okay, or any other parts, steel, aluminium, copper. Basically, you run it in a press and you stamp and create it in a particular shape and form. That is called as press shop. In my company, Nash also, we run a press shop, multiple presses. Okay, so they were able to reduce the unplanned downtime by 25% of this. And the plant connected system was also scalable. So it allowed new application to be integrated much faster, almost 80% faster than before. So you should read this. I think this is a very, very interesting case study. I think in my second version of my book, I'm writing the second part of my book, Confluence of AIT, AI and IoT, part two, you can call it, which will be called as Convergence of Hardware and Software. I want to probably go deeper into this. Maybe I will get an opportunity to talk to somebody in the factory and understand. Okay, but let us also look at one more quick case study before we open up the floor for the Q&A. Two more I will cover. One is the smart home energy management. In fact, one of the startup called as Thingifiy, which was there earlier, they closed down. I think they sold off to someone. They did a case study in a home to understand what is the consumption of different lights and different electrical appliances in a home. So we are switching our gears. We are moving from industrial automation to a smart home. So it was my home actually, where we try to analyze approximately 6 months of usage of different appliances, um, and understood that the dining room, drawing room main light and the kitchen light are the two biggest culprit of the energy consumption. Okay, so my drawing room was consuming roughly 2,000 rupees, 1,700 rupees, and the kitchen light roughly 1,300, right? And then of course there are other lights here. So we said, okay, let's understand what is going on. I had deployed a motion sensor in my kitchen, so that the light can turn on and off automatically when somebody comes in and out. Because I love IoT, so I deploy it wherever I go. We studied the hours of usage also of that of those appliances, and it came out that kitchen light, the orange one, orange circle, and the drawing room main light, blue circle, is run approximately the same time. And then, of course, there is my bedroom light, lobby entry light, fan, and etc. So when we studied the weekly trend of those appliances, we created some idea to understand what number of hours that they consume. So you see the orange line at the top, the kitchen light, it runs the highest amount of time, right? And then of course there is green, there is yellow, which is corresponding to the different applications. So we said, okay, why don't we go deeper using some analytical algorithm to understand the data and find the hours of the day trend. So we also saw that in which time of the day I start and use which light. So I figured out that between morning 7 a.m. till evening 8 p.m., the kitchen light is continuously used throughout the day. Okay, sometime more, sometime less. So we went deeper into the kitchen hourly trend, and we realized, and the company realized, the startup, that the amount of energy consumed by the kitchen light between morning 7 a.m. till afternoon 3 p.m. is quite high. And we quickly made it out that the motion sensor is definitely is a problem. So because maybe we should do something better. And we implemented an ambient sensor, an ambient light sensor, lux sensor, to understand the amount of ambient light coming into the room from the kitchen window and probably from some surrounding area. And we started deploying some area to say that the motion sensor should only get activated when the ambient light intensity is below a certain threshold. And that's where we realized that we could save roughly 400 to 500 rupees of the bill in the period of I think 3 months, if I'm correct, uh, by ensuring that the light does not get turned on when there is sufficient ambient light or the sunlight coming into the house. Okay, so you can see the power of technology, right? Think of this, if I extrapolate this to a larger bungalow, to a larger house, or to a Ambani's house, right? How much energy I would end up saving? I don't know. God knows. Maybe they will not care so much. But I think what is important that the powerful impact of this technology is available and clearly visible in many use cases. Um, Another use case, I think we are running out of time for today, but I will leave a brief snapshot to you. We'll cover in the future sessions. Tata Communication and Tata, they implemented energy management in a transformer monitoring system. Okay, so like I just explained, I did energy management in my home. They implemented a solution in a power line transformer, right? So, transformers are very big devices. They are very big machines. They have a lot of heat that they generate when they run to manage the grid lines and the power lines. So what they did is they studied the different failure points in the transformer. If you see on the top, the first screen here, this part, right? Uh, they identified 5 touch points. Okay, They set the cooling protection. Okay. Then they identified, one second. So they identified the cooling protection. They looked at OLTC, which is the top panel, the coil protection, the thermal protection, and the overload protection area. So these are the areas which are typically required to monitor the health of the transformer, right? And they deployed some sensors, okay, temperature, humidity, vibration, and few area to monitor the heat generated by the different parts. And then they implemented a SCADA system, okay, to read this temperature in the different time of the day, different month of the year, during the day, during the night, during summers, during winter, etc. And then they created a dashboard, a very nice dashboard that you see right here, which basically can tell you the status of every part here. Technically, if it is green, it is good. If it is orange, it is actually getting onto a borderline. If it is red, then it is probably in a risky situation and maybe have a shutdown. So they created a complete remote monitoring of the entire transformer to implement what I call as preventive maintenance, right? So they were monitoring the load and using a basic data analytics, they were able to create a very good alerting system to the operator, which will basically generate an alert whenever a particular part or a machine part is going to fail because of the extra heat generated, right? And then, of course, they enhanced this to other use cases gradually. But as you can see, with a simple temperature sensor, a connectivity or the network, they use a local Wi-Fi and a simple solution. I'm able to understand the status of a very important device, which is a transformer, right? Think of the day when all the transformers are run to the most efficiency without or almost zero downtime. You might likely have very less number of power cuts. Of course, there are other reasons of power cut as well, not just the transformer, but it's also about your grid, about your power line, your local network and other thing. But this is very powerful, right? So that's the last case study. I do have more case studies, which I will cover in the future for all of you. Black& Decker is one of them, which I've also studied in depth. Then there is another of quality assurance in an EMS line, which I also did study, and it is part of my book. And there are a few more, okay? But I think for today, these are some of the case studies. So I will leave all of you now with the thought that if this session was useful for you. I will leave it two notes with you. That one is, if you wish to talk more about AI and IoT, I'm always approachable. And if you wish to, of course, purchase my book as an author copy or online on Amazon, you can definitely scan this QR code and download it. I've just launched my own website, vinaysolanki.com. So you can follow me there, or